haven't, raise your hand if you've actually done this integral before. If you looked at this last year. You kind of have, probably, because it's one of the first ones you integrate when you learn a new integration method that you don't need for the A/B test, but you might have seen after, or it might have been mentioned by Mr. Whipple. It's also, it gives you like a false sense of security because you see ln, you're like, oh, it's like e. When you integrate e, nothing happens. So I saw people do this and just like drop the integral sign and just leave it as, no. You have to integrate ln x. Does anybody know the method you need to use to integrate this? Does anybody know? Yeah, it's not. It's by what? Integration by parts. Integration by parts. Integration by parts. Does anybody remember how integration by parts works? Okay, ready? Let's do a quick review. We'll quick review, and you guys are gonna help me through it. Okay? No, there's two actually, and I'll show you what the two parts are in a second. Okay? So here you go. You ready? So if I have two functions, and for some reason they use u and v. I don't know why they use u and v, but I'm so comfortable with it, we're just going to deal and move on. If I have u and v, what's the derivative of uv? U prime v plus uv prime, right? Do you agree with that?
Yeah.
Okay. If I integrate both sides, I can go back to where I started on the left. Let's say I integrate both sides. So if I integrate the left, what do I end up with? You agree with that?
Yes.
So I end up with uv equals the integral of this thing, uv prime plus uv prime, like this, correct? You with me so far?
Yeah.
Okay, so if I have the integral of the sum of two things, what can I break that apart into? Separate integrals, if I wanted to, right? So your job is to make sure I don't make any small mistakes. You with me so far? Okay, so what do we have here? uv is equal to the integral of u prime v plus the integral of what? uv prime. You with me so far? Okay, so what you then can do is it doesn't seem like it's super helpful, but I'm going to subtract one of the integrals. Let's say I always pick the wrong one notationally, but is it still okay to say this? Is that okay? So I'm just going to change the order here. The integral of u prime v is equal to uv minus the integral of uv prime. Are you with me? Are you okay with this so far? Yes. Okay, so this might not, all we've done really is it kind of seems, what's the right way to say it? Not super useful. It actually is really useful. It is really useful. Here's why, okay? So what we're looking at here, so let's take this. Let's look up in the upper left. We have the integral from 0 to 1 of ln x, and there is a problem with that 0 there, which we'll deal with by turning it into a limit. That's why it's an indefinite interval. This right here, the left side here, correlates to what we have, what we're starting with. There are two parts. There are two parts. What's the first part? ln x. What's the second part? dx. dx is the second part, okay? So watch what happens. We're going to just try this and see what happens. So what I'm going to do, everybody, is I'm going to say, ready? I'm going to say that, let's say u was dx. Let's just go with this and see what happens. Let's say u is dx, and let's say if u is dx, what does that make v? We're turning this into u times v. This. Hold on. The order doesn't. Okay. So you want. So you notice something here. So we're trying to build u prime and v. So what are we going to say u prime is? dx. And what is v going to be? ln x. So if that's ln x, what's v prime? Is that okay? And what's u going to be? X. Okay, so now what we do is we take this rule and we apply it right here. So therefore, what is our new integral going to equal? It's going to equal u times v. So what's u times v? X ln x. That is u times v. Are you with me so far? And what are we subtracting? The integral of what? U, which is x, times v prime, which is what? 1 over x. Are you with me so far? So what do we have here? X ln x minus the integral of what? 1, and we're integrating with respect to x. I'm being a little messy with my notation. Where's dx? Where did I put it? Dx is in the original. So this right here, dx is right there, and our v is right there. That's what we broke it up into. Dx is the u prime, which is right here. There's the u prime. I just switched the order here. So the idea is we're breaking it up now into uv minus uv prime. This is u right here, right? This is v minus uv prime. Where's what? Okay, yes, dx. There you go. Are you talking about that right there? Yes, you're taking the integral. So there is. I'm being a little messy with my notation right now, but I'm giving you the hand wave because you don't need to do this every time. That's why I'm doing it this way. So if you're integrating 1, what does that come out to be? If you're integrating it with respect to x, it's x. So this equals x ln x minus what? X. It's going to the right, correct? Just to be clear here, because we're going between 0 and 1. It's approaching 0 from the right. So we would like to think we are done at this point, right? Do you agree? You would like to think you're completely done? Well, that goes to 0. So if we simplify this, what do we now know? This goes, it's close to being done. This is going to 0. Oh, this 1 is still around. We don't really care about that. But what's our problem at this point? What's the problem at this point? Okay, you can't plug in 0. It's a limit, right? The thing we don't know about is this. We can't just say we know what this is. The limit as b goes to 0 from the right of b ln b. Do you have any idea what that is off the top of your head? That's what I'm saying. Do you know? I'm asking you that question right now. This part of this big limit is the problem. Because is it obvious what this does? Is it? Looks something like this, right? Mm-hmm. So what's going on? What's happening to this? This is going to negative infinity, and this is going to... When you multiply 0 times negative infinity, just straight up, do you have any idea what happens? You absolutely do not. This is getting arbitrarily small, this is getting arbitrarily big, and you're multiplying them together. They are going to fight it out. You have no idea at this point what it is, because now it tells you in the preamble to the question, it actually gives you a hint of what you have to use at this point. Does anybody know what you have to use at this point? You have to use L'Hopital's rule on this one. You have to use L'Hopital's rule on this one. 0, something going to 0. Look, we already talked about this, right? If you have a sequence that's getting smaller and smaller and smaller, going to 0, and if you add together all the pieces, does it necessarily converge or diverge? It depends. Exactly. So just because it's getting infinitely small doesn't mean when you add them all together that it will converge, right? 1 plus a half plus a fourth plus a eighth plus a 16th, that goes to 2, right? But what about the harmonic? 1 plus a half plus a third plus a fourth plus a fifth plus a sixth. What happens to that one? It diverges. So just because something's getting infinitely small doesn't mean it's going to go to 0, right? This part is getting infinitely small, but what about this? It's getting infinitely big. It's getting negative, but it's getting infinitely big. So you don't know automatically what happens when you multiply them together. It depends on how fast it's going to negative infinity, and it depends how fast this one is going to 0. So what do you have to use at this point? Someone just said it. L'Hopital's. Can you make there be division? And my English is slipping. Okay. Limit as b goes to 0 from the right of, ready? ln b over 1 over b. Have I changed anything? No. Mathematically, kinda, but is this the same as this? It is, right? Okay, if you go to 0 from the right, what does this go to?
1 over 0 pushes.
Stop saying that. What is the limit as b goes to 0 of 1 over b? Infinity. Thank you. What about up here? negative, but it is an indeterminate form. So now do we have an indeterminate form? Can we now apply L'Hopital's rule? We sure can. So if we apply L'Hopital's rule on this, you take the derivative of the top and you take the derivative of the bottom. This is going to be the limit as b goes to 0 from the right. What's the derivative of ln b? Oh, and these are all, oh, it is b. Yeah, sorry. It's 1 over what? Over, what's the derivative of b, 1 over, what's the derivative down below? B to the negative what?
2.
Negative 2.
Negative b to the negative.
Like that? Is that correct? Okay. Let's try this again. The derivative of ln b is going to be b to the what? Negative 1. This is b to the negative 1, so it's going to be negative b to the negative 2. Can we clean this up a little bit? We sure can.
It is negative b.
Yeah. The derivative b to the negative 1. If you differentiate it, it's negative b to the negative 2. That's how we got that. You differentiate that.
B negative 2 over negative 2.
Okay, I'm confused. Become
Negative b to negative b.
limit as b goes to 0 from the right of what? Just negative what? B. What does that equal? 0. So what have we proven? This goes to 0. So what does this whole thing equal? Negative 1. Done. So in this case, if you were to just crank through this, you'd be like, okay, it's going to be, well, this is the integral from 0 to 1 of v to the negative 1 dv. Well, what's the integral of v to the negative 1? ln, right? ln of v, correct? From what to what? 0 to 1. So if you were just cranking through this, what is this going to end up being? ln 1 minus what? ln of 0. What's the problem with that? ln of 0 doesn't exist, so what do you have to do? No, just because I've shown you L'Hopital, so just because it says you could be using it, doesn't mean you're going to use it on every single one. We actually need to turn it into a limit. We haven't turned it into a limit yet. So what do we have here? We should, and we're like frowny face right here. We don't like that, right? So what do we have here? We have the limit as b goes to 0 from the right of ln of v from 0 up b, sorry, like this. Are you with me so far? Yeah? So now what do we have? We have the limit as b goes to 0 from the right of ln 1 minus ln of what? B. Well, what does ln 1 go to? Or what is ln 1? 0. And as b goes to 0 from the right, what does this go to?
Infinity.
Negative infinity, right? So what does this whole thing blow up to? So does this diverge or converge? The integral diverges. Does that make sense?
Why is it negative?
Once again, it's going to be minus minus. Sorry. So it's minus. It's this ln b as you go to 0 from the right. This goes to negative infinity, but it's minus it goes to positive infinity. Yeah, correct. So guess what? We didn't have to use integration by parts or L'Hopital's rule. Cameron is not impressed. Are you entertained? Come on, doing my best here, okay? Okay, at least I'm amused, okay? At least I'm amused. Okay, we'll do one more before we need to shake it up a little bit, and I'll get you moving around. One more. 15? We can try. We can try to do. Stop. PDF, stop it. Stop it. Where'd it go? Where'd you go? Where'd it go? Did I go too far now? Oh, there it is. 15? You want to do that one? Ooh, that's a fun one. Hey, at least it's different than the ones we've done so far. This is cool. And what subject does this broach into? Anybody want to tell me? What do you need in order to do this one? I'll rephrase. Anybody know?
Was it the same thing we did yesterday?
Yeah, it's very similar to what we did yesterday. It's very similar.
But I looked at the table of integration.
Stop looking at tables. Stop looking at tables. Stop it. Stop it. When you look at this, what should you think to yourself? That you have to recognize something. You have to look at that and read the tea leaves. N, D, dx of sine inverse x is equal to what? 1 over 1 minus. Yay! So what does sine inverse x equal? The integral of this thing, right? Right? Dx. Thank you. So we go over here and we're like, oh, we're almost there. We have a weird, this is an indefinite integral with arc sine. Man, how cool can your morning get? Can't even get cooler than this. So if we were to show all the steps here, what number do you suddenly not like in there? Yeah, you're like, I hate the number 16. Even though historically, in your career, I bet you've liked the number 16. It's got 2's in it. It's like a square. You're like, awesome. But in this case, you're like, not cool. Not cool, dude. Okay, so you do that cool thing where you have to, you factor out. You want that 16 to be factored out, right? So what do you actually, what's going to appear when you pull that 16 through the square root sign? So you end up with this like 1 over 4, 0 to 4 of dx over the square root of 1 minus x over 2 squared. I am condensing a lot of work right there. Can you follow what I just did right there? Kind of. So look, when this 4 crosses through the square root sign, it gets squared, right? So that becomes the 16, right? Inside here, x over 2 squared is x squared over 4, right? When that, oh, should that be, that's not a 2. Should be a 4. Thank you.
Oh.
You with me?
Yeah.
So why do I have to bring a 1?
Got it? Because it has to go in the denominator, not the numerator, to answer your question. Okay, now are we pretty good? What can we use? Not yet. What can we use? U substitution. Oh, thank you. U substitution. Nice. Okay. What's U going to be? X over 4. So du is 1/4 dx, and therefore dx is what? 4 du. We substitute that in, and we get 1/4 the integral of, instead of dx, we write 4 du over what? The square root of 1 minus what? U squared. What did I not write in yet? Limits of integration. Yeah, what's the bottom one going to be? 0. What's the top one going to be? 1. No, it's x over 4. These are x values, right? We plug the x right there, 4 over 4. Okay, we're getting there. What can we factor out now? What can we can factor out a 4, so you end up with 4 over 4, 0 to 1 of 1 over the square root of 1 minus u squared du, correct? Oh, that's kind of nice. What happens to the 4's? Bye-bye. So now we have this nice thing that's much nicer, isn't it? Because we know what that integral is. What is it? Yeah, so the first thing we have to do, though, is so if we do this out, you end up with sine inverse of u, correct? From what to what? From 0 to what? 0 to 1. If the sum of the absolute value of all the terms converges, then so does the sum without the absolute value. So if you can prove that the absolute value of the term, if you have something that's like alternating, like plus minus, plus minus, plus minus, if you can prove that all of the terms that went positive sum to a convergent, like an actual finite sum, then if this then so does this. Does that make sense, everybody? We're not proving this, which is fine. This is just some truth you get. Here's the key. The reverse is not true. The reverse is not necessarily true. So if this converges, then this. But if this converges, who the heck knows? You don't know. Understand the words. We're not doing a proof for this. This is the kind of thing that's beyond the scope of this class. So for example, this one right here, 1 minus a quarter plus a ninth minus a 16th, right? This right here is alternate, minus, plus, right? We don't really, okay, how can we attack this? Make them all positive. 1 plus a 4 plus a 9. That's 1 over n squared. Does that converge? Yes, because it's a p series with p greater than 1. So because the absolute value converges, because the absolute value of each thing converges, when you sum, what does it mean about this series? It converges. So one method of attack, just take the absolute value of everything and see what you can do with it. This is another like sanding method. You get to get rid of all the negative signs and see if it converges. But again, does the reverse work? Not necessarily. So you can't make that assumption. So this right here is the big, if all the things you're going to have to look over and over again. Like we could spend an hour just staring at this, and you're still going to need more time in your life to talk about this. Where did my mouse go? Where'd it go? Hello. There it is. Not sure why this is bouncing around like this. Let's pause this for series AN. Suppose the sequence of ratios has a limit. So what does this mean? Just to deconstruct this. This means the next term. This means the term and the next term. So one thing you can do is you can look at the limit of the current term expressed with n and the next term and see if it comes out, and see if that is approaching a limit. You see if the ratio is approaching a limit. So remember, if this was a geometric series, would you always get the same number? Yeah, 3, 9, 27. The ratio would always be 3, right? But in this case, maybe the ratio is approaching a limit. Some number. Here's what you get to figure. Here's the payoff right here. If you get a number L less than 1, then it converges. If it comes out to be greater than 1, or if L is infinite, then it diverges. It should kind of make sense. They're yeah.
Series just like how R is.
Correct. Correct. If L equals 1, so it's not quite a geometric, but it's approaching the behavior of a geometric, right? So therefore, the same rules should kind of apply. Again, we're not proving this, we just get to use it. If L equals 1, this is the one where it's really frustrating. If L equals 1, the test does not tell us anything about the convergence of AN. So you're going to do some nasty ratio test, crunch through some terrible algebra, and be like, victory is mine, the answer is 1. Like, and it tells you nothing. Okay? But this is a pretty straightforward test. You take the general term, put an absolute value around it. Take the next one, put an absolute value around it. And when I say take the next one, all you're doing is plugging in n plus 1 for n. That's it. By far, in my opinion, the hardest part about using the ratio test is the algebra itself. Because you're going to have n plus 1s, you're going to be like canceling factorials and crap. It's going to get nasty. I'm just telling you right now, be careful with the algebra. Be careful with the algebra. So I want to show you a few things, and if we have time, we're going to circle back and do a couple examples. But I wanted to show some of these. So for this one right here, you have to be real careful. What is, in this case, AN? Let me just shut this and open this again and see if it comes back. You know what AN is. What is AN? Oh, that's nice. It's not responding.